All right, for this explainer, we're going to put on our detective hats. Why? Because we're about to solve a really cool mathematical mystery, proving something that honestly seems impossible. Let's follow the clues together, step by step.
So this is the big question, right? This is the heart of our case. You look at a number like the square root of 7, and its decimal just seems to go on, with no pattern. But how do you actually prove that? I mean, you can't just sit there and watch it for eternity. That's the puzzle we need to crack.
To solve this, we're not going to tackle it head-on. No. Instead, we're going to use this brilliant, kind of sneaky technique called proof by contradiction. Here's how it works. We start by assuming the exact opposite of what we want to prove is true. Then, we just follow the logic until, bam, we hit a wall, a complete, undeniable, logical impossibility.
Okay, let's officially open the case file. Our main suspect is the square root of 7. And the charge? We're investigating if it's an irrational number. So our strategy is to assume its alibi is true. We're going to assume it's actually a rational number, a simple fraction, and we'll see if that story holds up under questioning. Now, what's really interesting here is the fine print. For a number to be rational, sure, it has to be a fraction, a over b. But here's the absolute key. A and b have to be simplified as much as possible. They can't share any common factors. They are co-prime. This little detail, it's the key to our entire investigation. You got to remember that.
Every good detective needs the right tools for the job. So, before we start the interrogation, we need to pull one very specific, very powerful theorem from our logical toolkit. This is what's going to help us uncover the truth.
And here it is, Theorem 1.2. Now, I know it sounds a little academic, but the idea is actually super simple. If a prime number, like 3, 5, or in our case 7, goes into a number that's been squared, then it must also go into the original number itself. This is the special key that's going to unlock this whole mystery for us.
And this just shows you exactly how it works in practice. Let's take the prime number 5. We all know 5 divides into 100, right? Well, since 100 is just 10 squared, our theorem guarantees that 5 also has to divide into 10. And it does. Simple, right? We're going to use this exact same logic in our proof.
All right, tools are ready. Suspect is in the room. Let's begin the interrogation. Like we said, our first move is to assume the suspect's alibi is solid. Let's just pretend for a moment that the square root of 7 is a perfectly normal, rational number.
So let's get into the math and see where this leads. If we say root 7 equals a over b, the first thing we want to do is get rid of that annoying square root, so we square both sides. That gives us 7 equals a squared over b squared. We do a little bit of rearranging, and we find our first major clue. 7 times b squared equals a squared.
So, what is this equation actually telling us? Look closely. It says that a squared is equal to 7 multiplied by some other number. Well, that can only mean one thing. A squared has to be divisible by 7.
And boom, this is where we get to use our special tool. We just found out that the prime number 7 divides into a squared. So according to our theorem 1.2, that means 7 must also divide into a itself. This is the first crack in our suspect's alibi.
Now let's press our advantage. If a is a multiple of 7, we can just say a is equal to 7 times some other number. Let's call it c. Now we take this new piece of info and plug it back into our clue. We replace a with 7c. Which gives us 7b squared equals 49c squared. We simplify that down, and suddenly we have a brand new equation, b squared equals 7c squared.
And would you look at that? It's the exact same situation all over again, but this time it's for b. This new equation clearly shows that b squared is equal to 7 times something. So that means b squared must also be divisible by 7.
So you know what that means. We get to use our theorem a second time. If the prime number 7 divides b squared, then it has to divide b as well. And with that, we've just uncovered our final critical piece of evidence.
Okay, time out. Let's pause the interrogation and just step back for a second. We need to look at what we started with and what we just figured out. Because when you put it all together, the whole story just completely falls apart.
This is it. This is the moment of truth. On the left, we have our starting assumption, the suspect's alibi, that A and B share absolutely no common factors. But on the right, we have the evidence we logically uncovered. A is divisible by 7,
and b is also divisible by 7, which means they both share a common factor of 7.
Let that sink in for a second. How can two numbers share no common factors and at the exact same time share a common factor of 7? That just doesn't make any sense at all.
And the answer is, they can't both be true. It's impossible. This right here is the smoking gun. We've reached a logical contradiction, an impossibility that proves our suspect's alibi, our initial assumption, was a complete lie from the very beginning.
And just like that, the logical chain has shattered. Our assumption led us to an impossible result, so now we can finally close the case and reveal the truth. This is the incredible power of proof by contradiction. The only way we could have possibly ended up in this nonsensical situation is if our starting point was wrong. The assumption that the square root of 7 could be a simple fraction has been proven, definitively, to be false.
And if it can't be rational, well, there's only one other possibility. Therefore, the square root of 7 must be an irrational number. Case closed. We've just proven the impossible.
And that leaves us with a final thought. We just used pure logic to prove something about infinity. This method, this proof by contradiction, is one of the most powerful tools in all of mathematics. It really makes you wonder, doesn't it? What other huge, impossible truths are just waiting out there to be proven by this very same method?